This is Lab 1 for Introductory Physics, the Coursera class. First, I recorded a video on my cell phone and uploaded it into Tracker. 10 values were recorded approximately every 42 hundredths of a second. Next, I calculated the initial velocity here and then plugged it into the Python code that we were given. After running the code and uploading first the data that was recorded in Tracker, which can be seen in this column, and then the computational approximations, and then put them in a graph. The first approximations are shown here. The green line is the code from Python. The red line is the actual observations. As we can see, there is a large divergence between the red and the green lines. So I decided to start at the first break and approximate the initial velocity from here, which is at approximately the first second. So the initial velocity, the second initial velocity that I calculated was about 2.5 centimeters a second. Then I plotted, starting at that time point, which is right here, I plotted that data all the way to the end. As we can see, there is still a large gap between the red line and the blue line using our second approximation for the initial velocity. This implies that the shoe that was dropped in the video was still accelerating when it hit the ground. So first, there were a few things I needed to change in the code. First was the vectors for the position and the velocity, since in this video we are moving in the y direction and in the class lectures everything was moving in the x direction. Second, the value for delta t is an approximation. Everything is recorded every 42 hundredths of a second, but it's really not. Here in Tracker, everything is not recorded every 42 hundredths of a second. This is approximately 43. This is approximately 0.45. So this was really just an approximation over time. For the computational model, that error had to be introduced. And so when I did that, in order to just continue that over time, I instead used a count variable and then used that to iterate over the loop instead of setting a preset value like we did in the lecture. Then second, in order to actually get to this time step here, so I chose this value for the initial velocity the second time because this is where the first break occurs. You can see a very clear deflection point. And so I used a constant value for the first 4 values, and then over here it starts to accelerate, or you can see the constant velocity from this point. And that really helps illustrate the data that is observed is actually accelerating. The shoe is accelerating when it hits the ground. And then for each simulation, I just outputted it to the Excel file like we used in the lab code, and then put all of the observations and simulations into one Excel spreadsheet and then graphed it. That is all.